Calculus BC, Lesson 1.4, Parametric Equations. So, this is a little bit different. It took me a little while to go back and figure out how to do these. But, what is a parametric equation? Well, let's talk about a rock thrown through the air. And it leaves your hand here, travels until it hits the ground. That's a parabola, and people say, oh, that's easy. Y equals negative x squared plus, I don't know, 5 feet in the air when you let it go, and we'll change this up so there's a variable up front, figure it out, and so on and so on and so on. Well, that's fine and dandy, but how long did it take to travel? And this is a question that I've never considered before. We need 3 variables for something in motion: the x and y position it occupies in space, and how long it takes to get there. So that's what a parametric equation does. There's lots of other reasons for it, especially in calculus, but that's why it exists. We have a parameter, the 3rd variable, typically t for time, that we introduce. This is challenging stuff. It takes some getting used to. It's kind of like learning a new language. However, we can use our calculator to do a lot of this. So I will show you how to do that once, and then we'll go from there. So here's the equations. X equals radical t, y equals t, and t is greater than 0. So we go and hit mode. We'll go down to function and go over 1 to parametric. When we hit y equals now, we get something different. Square root, and when we hit x, we get the t, which is nice. Y equals t, I think it said. I'll have to double check. Yeah. So I can just put in t, hit enter, and then graph. Notice it stops because when I hit window, it says, well, t only goes from 0 to 6.28. So if I want t to go further, I have to say, send it to 10, please, and graph it. Now it goes up. Oh, wait a minute, I want it from negative 10 to 10. And now we get, hopefully, some of the other side. No, so I'm still experimenting, figuring out what's going on here. Should have worked. Doesn't matter. Something you need to be aware of is all I'm getting at. Now you might look at that and say, that's a parabola. Why don't we just graph it as a parabola? Like I said, we need to consider when we need an extra variable to define something. Enough. You'll play with it, you'll figure it out. Well, how would we do that otherwise? Well, got a 3-way chart here, which I don't think I've used yet. If t is 0, x is 0, y is 0. If t is 4, x is 2, y is 4. 1, 2, 1, 2, 3, 4. At which point you say, well, wait a minute, where's the t on the graph? And I said, it's not there. So I have to define it parametrically. Very, very confusing stuff. That's the initial point. Where it starts. Where's the terminal point? In this case, there is not one. But what direction does it go? What do you mean direction does it go? It's a curve. Yeah, it starts there and goes. The t gives it direction. So I put a little arrow meaning that it's going this way. And it goes forever. That's not a dot. That's an arrow. So let's start playing. Domain is very important. We call the domain I for the parameter interval. That's the t thing up here. But you don't need to worry about that yet. So here's the definition. X is f of t and y is f of t over an interval of t values. The set of points is a parametric curve. We parametrize things, parametricize things. I don't know, I keep putting it into Word and it keeps telling me this works and that doesn't, so who cares? It's a parametric equation. Like I said, notice direction matters. It determines where the curve starts, the direction it goes, and where it ends if it does end. It also may not start. It might be infinity, forwards and backwards. So let's give you one of the more typical examples it's used for. X equals 2 cosine t, y equals 2 sine of t, 0 less than t less than 2 pi. I honestly did not do this one before. I just threw it in the calculator and said, let's see what happens. T is 0, cosine of 0 is 1, 2 times that. Sine of 0 is 0, done. Let's go pi over 2. And let's start graphing this thing. First point is 2, 0. 1, 2, 0. This is my initial point. Pi over 2, sine of pi over 2 is, cosine of pi over 2 is 0. 2 times 0 is 0. Sine of pi over 2 is 1, 2. Now we're up here, and I happen to know it does that. If you want to check, put in pi over 4. Can't put my arrows in yet. I like to use green. Put in pi, we get negative 2 and 0. Cut to the chase, 2 pi, we get 2 and 0. This is also the terminal point. Notice without me labeling it, you'd have no idea if you just came across this graph. And it goes around counterclockwise. What's going on here? What's x squared plus y squared if this is what x and y are? Well, it'd be 2 cosine squared plus 2 squared sine squared, which is just 4. And you know what, I'll leave it as 2 squared. Cosine squared plus sine squared, hence the reason we do trig before calculus. X squared plus y squared equals 2 squared. Why did I leave it as 2 squared? Because that tells me the radius. It's a circle of radius 2. Don't want to do that again. Let's be as lazy as humanly possible and go here. Clear, clear. I believe that's at 3 cosine of t, 4 sine of t for y, zero to 2 pi. I'm going to go in the window and I'm going to define it. 0, enter, 2 pi, enter. It'll probably tell me, yep, 6.28. That should do it. Graph it. Of course, it's not helping me out. Zoom 6. Don't know why that had to give me a hard time, but it did. Looks like a circle. Is it? No, it is not. It's an ellipse. It goes from 3, 0 to 0, 4. But notice by watching it graph, we could actually figure out what it's doing. Started here, went here, initial point, terminal point. What is x squared over 3 squared plus y over 4 squared going to be if I plug these x and y's in? They're going to cancel. You're going to get 1. You're going to end up with x squared over 9 plus y squared over 16 equals 1. It's an ellipse. So we can use parametric equations to define circles in an easier way, because if we take derivatives and integrals, something we're going to do a lot in calculus, of x squared plus y squared, it gets a little tricky. Lots of different ways to do things though. So you might at this point be like, oh, so parametric equations are just for like curved graphs of conics, parabolas, circles, ellipses. No, you can do it for a regular line segment. And I'm not going to do the 3 column here. I'm just going to say x equals 3t, so t equals x over 3, and I'm going to plug that into y equals 2 minus 2t, y equals 2 minus 2 times x over 3, y equals 2 minus 2/3 x, y equals negative 2/3 x plus 2. At which point you might be tempted to do a big long graph, but you have to remember it matters. It only goes from 0 on the x, 1, 2, down 2 over 3. So when I put in t equals 0, I get x equals 0, and I get y equals 2. This is the starting point. And then when I put in 1, I get x equals 3, y equals 0. So this is the terminal point. And it travels in that direction. So that's a line segment. We could have set t to go from negative infinity to infinity, and we'd have a regular one. You can check that on your calculator, which I'd highly recommend doing, and set the window so it's 0 to 1. Now how do you parameterize? How do you go backwards? How do you parameterization? You know what? I'm not doing it. How do you turn it into a parametric equation? Well, there's a huge missing piece here, and that's we get to pick what t is going to be. As I've done this several times, and it's not very clear by a lot of people who do this. Well, t is going to go from 0 to 1. Does it have to? No, you can make t anything you want. Let's default to 0 to 1. Then it actually gets to be quite easy. It's a y equals mx plus b thing. X first. X equals negative 2 plus a times t. Why'd I pick negative 2? I pulled this right here. Well, I don't understand. I don't get it. Well, remember, what we're going to start at is t equals 0. So this will drop out, and x will be negative 2. That'll give me my initial point. We'll do the same thing for y. Y
so
equals...
I'm jumping back in here. My apologies. And I've got no voice. I realized I made a major mistake. I carried a negative 1 down, which makes no sense at all. So I had to put a 1 there to finish the problem correctly. So we get 5 equals 1 plus b, and we make this one at 1 because the original was 0. And then we solve these. A is 5, b is 4, and then we write them out. X equals negative 2 plus 5t, y equals 1 plus 4t, where 0 is less than or equal to t, less than or equal to 1. Don't remember what I said and didn't say, so just trying to remind you that we pick the parameterization. We decide to make t go from 0 to 1. Tons of other different ways to do this. That's one of them. And it is just y equals mx plus b, although we put the b first here. Just how it's done. Thanks. Now back to your regularly scheduled program.
That's it. Happy mathing.